Hello and welcome to this Astranti YouTube video. Today's video is an extract from one of our tuition videos on the topic of sensitivity analysis, which comes up in both CIMA P1 and P2. So let's get started.
But one thing we haven't looked at yet is how sensitive a particular project is. We've just looked at comparing projects side by side and choosing the one with the highest expected value. But the sensitivity of a project is also a really good indicator of how risky it is. And with sensitivity analysis, one way you want to think about it is to think of it as a what-if analysis. What if A happens? What if B happens? If C happens? Etc. What will that mean for the project? And it's a really good way of analysing and assessing risk, because the more sensitive it is, the more risky it is a project. And what we're looking for in this section is understanding how much a particular factor can change before the project becomes unprofitable. So if you think about it like the factor being revenue. So revenue, how much can revenue change by before a project becomes unprofitable, becomes unviable? Now, if revenue can drop 40% before the project is unviable, it is not sensitive to changes in revenue, because that's a huge drop. But if the project becomes unprofitable simply by there being a 2% drop in revenue, then all of a sudden it looks very, very risky. All it needs is a very slight change in revenue, and all of a sudden we have an unprofitable project. And as with all things, this is best explained using an example, and that's what we're going to do now. We're going to look at a project where we're going to be selling t-shirts. So let's look at some of the various facts and figures required for our t-shirt project. Well, we have a selling price of £10 per unit, and each unit we sell will incur a variable cost of £4. So this is all the direct material, the direct labour, etc. that goes into producing each individual unit. If we don't sell any t-shirt whatsoever, we'll have zero variable cost. If we sell 100, then we're going to have 4 multiplied by 100, etc. We then have our fixed costs. These are the costs that we will incur regardless of production volume. So this will be things like the rent on a factory, etc. You'll have to pay this regardless of what happens. And we predict that we will sell 1,000 units. So the first thing that we need to do here is to calculate the expected profit. So let's take the number of units, which is 1,000, multiply that by the contribution, which is calculated by deducting the variable cost per unit from the selling price per unit, because that is how much each unit sold goes towards contributing the paying off of your fixed costs and getting you into profit. And then we deduct the £3,000 in fixed costs. So essentially it's 1,000 multiplied by 6 minus 3,000, which gives us expected profit of £3,000. So that's a good project to undertake. It's going to give us profit of £3,000. But it will be unviable if that profit drops to zero. If it drops to zero and we just break even, we cannot afford to undertake this project. We can't just keep it going even though it's not going to give us profit. So what we need to do now is look at some of these various different factors and look at how sensitive this project is to a change in those factors. And the factors we're going to look at are the sales price, the fixed costs, and the sales volume, so the number of units, and how much these would have to change by before the project becomes unprofitable. So let's start by looking at the change in the sales price. So basically what we want to know here is we need to look at the information and look at how much the sales price could fall by before the project becomes unviable. In other words, unprofitable. And the selling price is currently £10 per unit. So what we need to do here is that we need to basically work backwards through this expected profit calculation and find the sales price when profit is equal to zero. So let's start by bringing in our 1,000 units, because we're still predicting that we're going to sell 1,000 units, multiplied by the sales price, which we don't know yet because we're trying to find the sales price where it becomes unviable, minus £4, which is the variable cost per unit, minus £3,000, and we put that as equal to 0 because that's the point where the project becomes unviable. And we can rearrange this equation here by taking the fixed cost to the other side of the equal signs. We've got 1,000 multiplied by the sales price minus £4 per unit equals £3,000. Then we can divide each side by 1,000 to get rid of that 1,000 on this side and take it down to £3 on the other side. And we've got the sales price minus £4 equals £3. And so what that means is the sales price where the project becomes unviable is £7, because 7 minus 4 is equal to 3. And we can work this out as a percentage of our original sales price. So our original sales price being £10 per unit. And if it falls by £3 to £7, it becomes unviable, which means a reduction of £3 per unit is a 30% decrease. So it means that our project is 30% sensitive to the sales price. A 30% change in the sales price will render the project unviable or unprofitable. What about the fixed cost? How much would fixed costs need to increase by before the project becomes unprofitable? Now, this is a bit easier to answer because we already know what our fixed costs are and we know what our expected profit is. But let's put the equation back together. So we've got 1,000 multiplied by our contribution. Remember that our selling price and our variable costs aren't changing in this instance, minus the fixed costs equal 0. So again, as before, we will rearrange the calculation. We've got 1,000 multiplied by the contribution of £6 equals the fixed costs. So 1,000 times by £6 gives us 6,000 in fixed costs. So if fixed costs were to be £6,000, the project would be unviable. And as before, we can work out the increase as a percentage. So an increase of 3,000 is a 100% increase because fixed costs were originally £3,000. So if fixed costs double, then the project will be unviable. So it's perhaps a lot less likely to be affected by fixed costs. They're going to need to actually double before the project becomes unviable. And finally, the sales unit decrease. So we're not affecting the price this time. The price is still £10 per unit. We're talking about the actual sales volume. So how much reduction on that 1,000 units would we need before the project becomes unviable? So for the final time, let's bring back our expected profit equation and set it as equal to 0. We've got the sales units multiplied by that contribution of £6 minus 3,000 equals 0. Rearrange the equation. So we've got sales units times by £6 equals 3,000. And divide that 3,000 by 6 to give us the sales volume, which is 500. And we can see that we had predicted sales of 1,000 if we look back at the example, and it would need to drop to 500 before it becomes unviable. And this drop in 500 units represents a 50% decrease. So what we can read from this analysis is that it's not actually particularly sensitive to any of these different variables. It's not 2% or 3% or anything, but it does show us that it is more sensitive to a change in the sales price than it is to a change in the sales units or a change in the fixed cost. So that would be the primary variable, the primary factor to focus on, to control, because it's most sensitive to that particular variable.
So thank you very much for watching this video. If you found it helpful, don't forget to like and subscribe to our channel. Tuition videos are included as part of our complete operational level course, covering CIMA E1, P1, F1 and the operational case study. It's £500 cheaper than purchasing the individual courses separately and available on our website at astranti.com. We're also active on Instagram, Facebook and Twitter, so be sure to follow us on these platforms for more great content.